Live from the Stability and Trim for the Ship's Officers podcast studio, where the vessel's its own best instrument of stability and trim. Welcome. This is William George. Hello. This is podcast 19. We're covering chapter 10, the first part in Stability and Trim for the Ship's Officer, Longitudinal Hull Strength, and we're starting on page 217. In the 19 chapters of this text, Transverse Stability and Trim, which deals only with the overall hydrostatic properties and the ship's effective center of gravity, were discussed. It was assumed that the vessel was inherently strong enough to hold together under the proposed loadings. In this chapter, longitudinal hull strength covers the relationship between the longitudinal distribution of the ship's buoyancy and the ability of the ship to cope with the internal and external stresses applied to it by its weight distribution. Concerned persons are not limited to the ship's master and officers, but also the stevedores, ship loaders, port authorities, loading terminal authorities, commercial and technical personnel of shipping companies, and the owners. All persons involved must be conscious of the limits of the vessel's allowable hull strength in port as well as at sea, just as they are aware of the ship's GM and trim. By monitoring the vessel's hull stress through all phases of loading and discharge, major mishaps, such as pictured in figure 10-1, can be prevented. And if we go over to page 10-1, that's on 219, there is an aerial view of a 9-month-old integrated tug and barge, the Martha R. Ingram, after she broke into two while about to leave the dock at Port Jefferson on Long Island's North Shore. She had already discharged her cargo of oil. The mishap occurred in January 1972. It's apparent that today's modern high-technology ships are more likely to be broken in half at loading or discharging the berth than they are to suffer a loss because of the lack of transverse stability. To enable the ship's officer to cope with this modern-day possibility, the chapter will cover theories of strength of materials, properties of materials, longitudinal hull strength, the actual application of applied longitudinal hull strength aboard ships, and recommendations to avoid overloading bulk carrier structures. The ship is a structure. What is a structure? Anything that provides a safe space for a given activity is called a structure. A good structure should also be efficient. To be efficient, the structure should not interfere with the activity for which it provides the space. For example, a roll-on, roll-off automobile ship would be a good example of an efficient structure for carrying automobiles, but a poor one for carrying bulk grain. The autoliner has low decks to limit the lost space in the structure and virtually no pillars to inhibit the movement and stowage of the cars. Individual components of the structure are known as members. The dimensions of the structural members are known as scantlings. By controlling the size of the ship's scantlings, the naval architect can control the ship's ability to withstand the longitudinal hull stress. Therefore, think of the ship as a self-propelled ocean structure that is composed of structural members that contribute to its longitudinal hull strength. Strength of the structure. Hull failure will result aboard ship if the ship is not operated within the maximum allowable design stress, if the ship is built with defective substantial materials, or if the workmanship during construction was improper. So we have three things. We have the design, the materials, and the workmanship. The strength of the ship's structure depends on the balance of design, materials, and workmanship. By the time the ship's officer arrives on the scene, the ship is complete. The design of the vessel has passed the approval of the classification societies such as the American Bureau of Shipping. Workmanship in the yard and the materials used in construction have passed many inspections and tests. As a ship's officer, it's your job to see that the ship is operated within the limits of its design. You should always keep in mind that human beings have manufactured material and the fabricated the ship. While every effort has been made to make the hull as perfect as possible, do not forget that somewhere there could be a latent defect in workmanship or material. If there is a latent defect, especially in the midship section, the ship will not be able to withstand the longitudinal stresses for which it was designed. A wise officer will always limit his hull stress for these reasons. With less longitudinal hull stress imposed on the ship's hull, there will be less flexure to the hull, hogging and sagging, and therefore less metal fatigue. A wise officer also realized that the combination of metal fatigue and wastage, that's rusting, of the ship's hull due to rusting and corrosion, will limit the hull's maximum designed allowable stress as the lifetime of the ship progresses. Strength of materials. To obtain a comprehensive knowledge of the subject of strength of materials can be and does under certain conditions entail months of study and careful perusal of many full-length texts. In this book, the extent of the investigation will be limited to specific need for particular theories regarding the strength of materials. Although you, as the ship's officer, are not required to design a vessel, you are required to use its design in the best possible manner. With this purpose in mind, the following analysis of the subject was written. Preliminary stress definitions. All structures and all members make up structure are exposed to stresses of varying character and extent as follows. Tension or tensile stress as a result of two forces acting in opposite directions on the same line, always from each other. When tensile stress is applied to a material, it tends to pull the material apart, lengthening it in the process. A simple illustration of this stress, and as a result, is the stretching of a rubber band when the force is applied. Tensile stress is measured in force per unit area, that is, pounds per square inch, tons per square inch. Assume a deck beam has a total force of 90 tons, attempting to pull it apart. The cross-section area of the beam is 15 square inches. The tensile stress on the beam will be 6 tons per square inch. And that's illustrated on figure 10-2, and that's on page 220. Compression or compressive strength is a result of two forces acting in opposite directions in the same line toward each other. Here, however, the forces tend to compress or push the material together, and that would cause buckling, buckling, buckling. It is a typical type of failure when a member is placed under compression. Normally, a material will fail in tension before it will fail in compression. If the force is 90 tons on the beam, as shown in figure -2, and had been acting so as to produce compressive forces, it would also be expressed as 6 tons per square inch, because it would be 90 tons divided by the cross-sectional area of 15 square inches, as shown in the figure. The following two terms are used quite differently aboard ship than used when discussing strength of materials. Load, L-O-A-D, load, refers to the total force acting on a member or a structure and is expressed usually in tons or pounds. Load may be statically induced as a case of water pressure, hydrostatic pressure on the hull, or dynamically induced in the case of propeller vibrations. When the ship's officer considers the load on a vessel in regard to longitudinal hull stress, they are actually comparing the longitudinal distribution of the weight and the longitudinal distribution of the buoyancy. The upward and downward forces cause shear stress, just like a pair of scissors has shear stress throughout the hull, which results in placing the deck and the bottom plating in either tension or compression. Strain is the lengthening or distortion of a member due to stress, and we spell strain.
Hey, I just wondered how things are going.
Its units are expressed in an elongation or distortion per unit length. The use of the term strain here is
the
quite
daily
different
podcasting thing
from
with the
common
questions.
use aboard a ship.
It's minimum effort and maximum
Such
views.
expression as take a strain on the line.
I get minimum effort to do it. It's
talk
maximum
and
views because it's only like
stress
3-minute
line,
podcasts.
In tension.
Yeah, well, and I just did one for
Why
the
is
book.
steel
It
a
takes a
major
half hour to
use
cover
of building
something,
in ships?
and it's compared
The ship
to
is a man
just reading a
man's
license
largest
question. How
moving
long does that
structure.
take to read it twice? with
To
the right
build
answer?
such a large structure, the
You know what I
construction
mean?
material
So,
chosen for
but
the
it's
task
interesting
must
thing to
be
bend the curve
the
on.
following-
How
have the
many
following
people can
features.
look at things, how quickly.
There has to be sufficient strength.
So
It has
today
to
was
be
supposed to be the
rigid
day I
enough
was going to start my
and
Beyond
abundance,
Basic Stability and Trim
So
workshop.
you
which
have
didn't
enough to
happen.
build the structure with.
So
It has to have uniform quality, so it's
Damn.
a predictable material to work with. It must be easily fabricated, which means cut, shaped, and joined. Relatively, it must be lightweight, and it also must be economical, the cheapest possible suitable material.
yeah.
Mild steel and some improved higher strength steels are materials widely used in ship construction because they have
Yeah.
these features. Therefore, a generalized knowledge of mechanical properties of metal and specifically of steel is used in a ship's officer to commands a metal
Oh yeah.
vessel.
Well, like I said, I just wonder if we're really going to
And
start.
who
school's going to
is
start up in
obligated
June.
again, to specifically specify repairs to metal structures and is used metal in various ways aboard ship. Now, when we talk about mild steel, basically this is the same steel as in a metal coat
Oh,
hanger.
okay. Well, like I said, I'd like
And
to.
if you want to
I'd
try
like
an
to teach a
experiment,
course in
don't try to get yourself
July
hurt.
if it's available.
But see how many times you can full bends you can make on a metal coat hanger before the metal breaks. From my experience, it's about 5 full bends. Putting it through hogging and sagging, if you want to think about it at the point of inflection.
See, that's what I
So
figured.
it's
Before, in other words,
relatively
maybe they're going to
strong.
limit
It's
the class
relatively
to 5.
lightweight compared to other materials. It's probably 30 times stronger than wood. Mild steel is, and it's relatively cheap and can be
Well, the
fabricated
medical-
in
the
very
medical thing,
uniform methods. Now, we're not talking
The,
about
the,
iron plates. We're
So
talking
I
about
guess the
rolled
thing of it is,
steel.
if there's any, and they
They
need
can
anybody else to teach
manufacture
anything
steel
else,
plates
I'm willing to
of uniform
give it a
thickness and dimensions.
shot,
So it's relatively easy to
Because I'm
transport. It's
checked
easy
off
to
in those other courses are the basic stability and trim
Properties of
courses,
metals.
cargo courses.
Some of the most important properties of metals can be seen by referring to a stress-strain diagram.
Yeah,
And this is seen in figure 10-4.
I don't want to.
And that would be on page 222 if you're following in the book.
I figure
This diagram
that
results
you go to
from a
these
test
meetings, if there is
of
a
a
need,
specifically prepared
send them an email
piece
in a week or so.
in a machine that literally pulls the
I don't
piece
think you're
apart.
short of anybody though. Out
It can
there.
be seen from the diagram
The cruise
that if the
ships aren't
stress is applied initially and remains proportional to strain.
Well, they're not going to start till August.
So what are we talking about? We're talking about how much
The first
stress.
that'll be an experiment
If they can
for-
actually do
which is
NCL
the
strain,
first
how much
cruise
it's
ships in August.
elongated or stretched.
They're going to try to book people and take them
It's
out.
proportional to strain. So when you see the initial curve of this, it's a
That
straight
might be in the
line.
East Coast though.
It's proportional. It's lineal. And if you
Yeah, well, I'm
remove
saying
that
though,
stress
on the
when
cruise
you're
ship
in this
industry,
initial slope,
they're going to try to reopen in
the
Florida
material
someplace in
will
August
return to
with
its
the East
original
Coast, I
position.
think. But the thing of it is,
However,
it's like,
at the end of
yesterday
this
there was only 125,000 people that
proportionality
flew
for
instead of
elastic
2.5
limit.
million.
is a difficult to
So
locate
no one,
since
you
the
know,
curve
you
does
need
not
airlines
deviate
to get to the
sharply
cruise
from a
ships.
straight line. If
So
the stress is removed
it's-
within the limit,
I think they're joking
material
with
will
that.
return
It's
to
just
its original
just to
length.
keep their
the
creditors at
material
bay.
is stressed beyond the elastic limit.
But
However, it will be permanently distorted. And will
yeah, so I saw the
what
stuff you guys were doing
permanent
with
set.
the MyTag stuff.
again,
up
if you're
there,
playing with a metal
with the
coat hanger,
firefighting, that
you
part of it
can
is distance learning. and
do a
stuff.
small bend in it and it'll return to its
It's got to be
original
more
shape.
cost effective.
But
You don't
if
have
you
to go
bend it
someplace for
too
a whole
far
week or
and-
2 weeks.
And with too much strain, you will get a permanent bend in it, and that would be the permanent set. It is obvious that a designer must provide enough material